more we have seen in the last video. Here more more uh, number of transistor per chip doubles every 24 months thanks to scaling not at a chip but at transistor level, not in chip transistor level. Cutoff frequency increases but not exploited due to RF and power limitations. Parallelism. Cutoff frequency increases but not uh, exploited due to RF radio frequency and power limitations. That is parallelism. Cost per transistor improved also due to wafer scaling. Here in 1970, that is here plus 50 percentage dia multiply with 2 die by wafer divided by wafer. So 50 in 1970 50 millimeter 2 inch 2 inches. In 1975 100 millimeter mm 4 inch. And then 1980 150 mm 6 inches. In 1991 200 mm 8 inches. In 2001 300 mm 12 inches. In 2020 18 inches 450 mm. Here in 0.35 micrometer in x-axis, 0.25, 0.18 micrometer, nanometer, 90 nanometer, 65 nanometer, 45 nanometer, 32 nanometer, 22 nanometer, 14 nanometer, 10 nanometer, 0.001 transistor dollar by transistor relative to 0.35 micrometer, 0.01, 0.1, 1. Here in this scale here 300 mm 12 inches. Here wafer diameter 8 inches 200 millimeter wafer diameter is dollar per transistor relative to 0.35 micrometer. More in more here actually small is beautiful, but what to do with so many inexpensive and super fast devices. Here cost per transistor improved also due to wafer scaling capacity. Already we have seen cutoff frequency increases but not exploited due to RF and power limitations. Parallelism. Oracle SPAC 4.1 GHz 32 core M7 processor in 13 metal 20 nanometer FinFET TSMC technology featuring 10 billion transistors. Here 10 billion transistors. 10 billion transistors. Here once again we have to think, we have to remember scaling or not at the chip but transistor level, litho level. Okay. Core cluster, this one also core cluster. Here core cluster. Here also core cluster. Here SMPS, IO, Internet, Connect, coherence. This is it. Here L3, S and on-chip network. Here accessories, memory. Here also accessories, memory control. Here also accessories, memory control. Here also save core cluster. Here same like coherence, SMP, IO, interconnect. Okay. Then more than more. Diversion of technology applications. Ubiquitous computing, not only signal processing, but smart sensing, wireless communications, power control, multi-domain integrated systems, physics, chemistry, biology, medicine, multi-domain integrated systems. Here, in x-axis, markets, data processing, communication, consumer, automotive, industrial, medical, identification. In y-axis, that is in social trends, infotainment, communication, security, energy, transport, health. In data processing, what will come? Power efficiency in energy. In communication, wireless connectivity in communication, and smart sensor tags, security, ultra low power energy, personal health monitoring in health and communication. And in consumer, wideband tuning in infotainment, and here in consumer, smart sensor tags and motor management, cash free. Here smart key in transport, this will come in security under. Here smart key. Okay. Under in automotive, in infotainment, connected car. Under in automotive, security, motor management, cash free. Under in automotive, telematics in transport. Under in automotive, driver monitoring in health. Okay. In industrial, smart metering in energy. In medical, ultra low power, e-cluster, biosensor, this ultra low power in communication, in medical side, e-cluster in security, and biosensors in health. Identification, e-government, under security, automatic fare collection, transport, automatic fare collection and transport. This is side for social trends. In x-axis, in y-axis, in x-axis markets. Here, more diversifications of technology applications, ubiquitous computing, not only signal but processing, but smart sensing, wireless communication, power control, multi-domain integrated systems, physics, chemistry, biology, medicine. New challenges beside miniaturization, CMOS technology with the extra process modules, advanced mixed signal circuit design, AD, RF, MEMS, power and etc. Application specific packaging. Here in x-axis, more diversification. In y-axis, more miniaturization. Here 130 nanometer, 90 nanometer, 65 nanometers, 45 nanometer, 32 nanometer, 22 nanometer, 16 nanometer, baseline CMOS, CPU, memory, logic. Here analog RF, Passives achieve power sensor MEMS RFID in NFC. Here combining SOC and SIP higher value systems. Yeah, interacting with the people and the environment. Now digital content systems in package SIP. Digital in package SIP. System in package. Sorry, system in package. System in package. Information processing. Digital content system on chip. System on chip SOC. Silicon wafer, polished monocrystalline slice, periodic atomic lattice, flat side. Okay. Here 100 plane, here 100 plane, here 100 plane. This is x-axis. Yes, z-axis. Here, yeah, y. Here in between here a distance. In CMOS, this is in CMOS technologies. Okay. Here also in this lattice, periodic atomic lattice, x-axis 110, y 110 plane, a z-axis. Here in bipolar technologies, x-axis turbulent plane, y-axis turbulent plane, in between distance a, z-axis doping type crystalline plane. Here B 100, n of 100, in between 110, P triple one, n triple one, doping type crystalline plane. Here phi a lattice spacing, approximately phi a lattice spacing. Silicon wafer, polished monocrystalline slice, periodic lattice, flat side, obtained from cylindrical inodes. Okay, yeah. Here melting melting of polysilicon at 1425 degrees Celsius, 99.999% purity. This one. Introduction of the seed crystal. Beginning of the crystal growth. Crystal pulling at 25 mm per hour. Formed crystal 1 meter to 2 meter with a residue of melted silicon. This is Chokrovsky method. This is silicon wafer, polished monocrystalline slice, periodic atomic lattice, flat side obtained from cylindrical ingots, grinding, slicing and polishing, diameter grinding. This is diameter grinding here. Here grinding. Flat grinding, wafer slicing, wafer. 200 micrometer to 700 micrometer thickness bulk epitaxial silicon on insulator SOI. Edge rounding. Edge rounding. Here. Two side lapping. Here, that is here and here. Chemical etching. Surface polishing. Slurry head. Wafer processing. Patterning areas using photolithography. Resist coat. Resist substrate. Exposure mask. Positive tone. Negative tone. Develop